All right, today we're going to pull back the curtain on Kubernetes. We're going to follow the entire journey of a pod, right from the moment you hit enter on a command, all the way to a fully running container.
So, you've probably done this a million times, right? You've got your YAML file, you run kubectl apply, and boom, your app is just there. It kind of feels like magic, but it's not. It's actually this incredible coordinated dance between a bunch of specialized parts. So what's really going on in those few seconds? Let's dig in.
Okay, so this whole journey kicks off with the core philosophy of Kubernetes itself. You don't give it a step-by-step to-do list. Nope. You just tell it what you want the end result to look like. That single idea is the spark that ignites the whole process. Yeah, think about it. You're not providing a bunch of instructions. You're just handing Kubernetes a file that says, hey, I need 10 pods, and they should all be running Nginx. You figure out the rest. You declare the destination, and you trust Kubernetes to calculate the route to get there. So once you've declared your intent, your request gets sent straight to the Kubernetes control plane. You can think of this as the central brain of the whole operation. And this is where all the planning and all the decision-making happens, way before any real work actually gets done. The very first stop on this journey is the Kube API server. This thing is the main entrance, the single official front door for the entire cluster. I mean, everything talks to it. You with your kube control commands, and even other parts of Kubernetes itself. It grabs your YAML, makes sure it all looks okay, and gets it ready for processing. A really great way to think about it is like a reception desk at a big company. It takes your request, checks your credentials, confirms everything's filled out right, and then officially logs it. It doesn't do the work itself, but it is the gatekeeper that kicks off the entire workflow. So, where does that reception desk file all this paperwork? It stores it in etcd. You can think of etcd as the cluster's memory, its single source of truth. It's a super reliable database that keeps track of, well, everything, what you want to be happening and what's actually happening in the cluster right now. And right there, the second your request is saved, a conflict is born. The desired state in etcd now says we need 10 Nginx pods, but the actual state says we've got 0. And that difference, that gap, that's the trigger that makes the rest of the control plane jump into action. The first one to spot this gap is the Kube Controller Manager. It's really just a bunch of different controllers all working together, and their only job in life is to stare at etcd, looking for these kinds of differences. When it finds one, its mission is to start fixing it. It's this constant, never-ending loop. Watch, compare, and act. Sticking with our office analogy, if the API server is the reception desk, the controller manager is the HR manager. It looks at the company's goals, which say, we need 10 Nginx employees. Then it looks at the current headcount and goes, uh-oh, we have none. So its job is to kick off the hiring process for those 10 open roles. So how does it hire them? Well, it doesn't spin up containers, not yet. It just creates 10 new pod objects and writes them back into etcd. Now, this is a super important point. These are not running containers. They're just records in the database. Think of them like 10 approved job postings. Each one basically says, hey, we need an Nginx pod, but we haven't assigned it to a machine yet. And that's the perfect cue for our next specialist, the Kube Scheduler. This component has one very specific job, placement. It's constantly looking for any pods that exist in etcd but don't have a node assigned yet. For every single one of those homeless pods, it scans all the available worker nodes and plays matchmaker, finding the best possible fit based on things like CPU, memory, and any other rules you've set up. You can see the key difference here, right? The controller is the HR manager who says, yes, we need 10 new people. The scheduler is the office planner who looks at the floor plan and decides exactly which desk each of those new people is going to get. It's all about logistics and resource allocation. Okay, let's just pause here for a second, because this is a huge point. We've had all this action, the API server, etcd, the controller, the scheduler, all this stuff happening in the control plane, and yet not a single container is actually running, not one. The entire process up to this point has just been about creating a really smart, well-thought-out plan. The real action, that's what's next. All right, the plan is locked in. Now we move from the brain of the operation, the control plane, down to the hands of the cluster, the worker nodes themselves. This is where the plan becomes reality. So on every single worker node in your cluster, there's this little agent running called the kubelet. And its job is pretty straightforward. It just keeps checking in with the API server, basically asking, hey, got any work for me? Any pods assigned to this node? It doesn't wait for instructions to be pushed to it. It's actively pulling its assignments. Back to our analogy, the kubelet is the new employee who's just been told where their desk is. They arrive at their assigned node, see the work order with their name on it, and they get to work. The kubelet is the component that finally translates that plan in the database into actual running software on a specific machine. And here it is, the moment we've been waiting for. The kubelet sees a pod assigned to its node, it reads the pod's specification, and it tells the node's container runtime, like Containerd or Docker, hey, pull this Nginx image and fire it up. And just like that, your application is finally alive and running. Of course, a running container that can't talk to anything isn't very useful, right? That's where kubeproxy steps in. This component also runs on every single worker node, and its whole job is to manage the networking magic. It sets up all the network rules to make sure your new Nginx pod can talk to other pods and that it can be reached from the outside world. It's the traffic cop for the node. So there you have it, the full journey from a command to a running container. Now let's just zoom out for a second and look at the big picture, because it helps you understand why this whole flow, which might seem a little complex, is actually so incredibly powerful.
So let's just recap the whole sequence one more time. It all starts with you declaring your intent. The controller then sees the gap and creates the plan. The scheduler assigns the resources, finding a home for everything. And finally, the kubelet on the worker node actually executes that plan. Each piece has a clear, distinct responsibility, and that separation of duties is precisely why the whole system is so resilient.
This is a pretty handy cheat sheet for the whole team we just met. The API server is your reception desk. etcd is the official company database. The controller manager is like the HR manager, making sure you're properly staffed. The scheduler is the office planner, assigning desks. And the kubelet is the employee who shows up and actually does the work. Each one has a distinct role, and they don't step on each other's toes. And that brings us to the most crucial point of all. The entire system is built around this declarative model. You don't give orders, you describe an outcome. Kubernetes then gets stuck in this continuous loop, always trying to make reality match your declaration. And just as importantly, if a node fails and your pods disappear, that loop just keeps on going. The controller will notice the new discrepancy and start this whole process all over again to self-heal the system. And that leaves us with a final, pretty cool thought. This self-healing declarative system is amazing at maintaining a state you've defined, but it really makes you wonder, if the cluster can automatically fix itself when things go wrong, what other kinds of automation can we unlock? What happens when we start telling it to automatically adjust the desired state itself based on real-world traffic? But hey, that's a topic for another day.